So in this video, we're going to apply the difference quotient to a radical function in order to find the slope of all possible secant lines for that radical function. So it says use the difference quotient. So this is part A, just like in previous videos. Use the difference quotient to find the slope of every arbitrary secant line associated with f of x equals the square root of x plus 2. So part B, then find the slope of the secant line that contains the points 0, f of 0, and 4f of 4. And just like in the previous video, we noticed we don't actually need to know what these two numbers are if we're using the difference quotient, although it might be nice to see them in order to help think about what's going on. So in part B, we're going to be asked to find a specific secant line slope. If we graph the function f of x equals the square root of x plus 2, it's going to look something like this roughly. And if you plug in 0, you get square root of 0 plus 2. You get the ordered pair here, 0, 2. And if we plug 4 in, we get the square root of 4 is 2 plus 2 is 4. So we input 4, and the output's going to be 4. So in part B, we're being asked to find the slope of the secant line that passes through those points. And of course, we could use these ordered pairs to find that slope, but the idea behind the difference quotient is it's going to give us a way to find slopes of tangent lines, and we don't need to know the function value at the input variables to use the difference quotient. So we'll start off with part A using the difference quotient to find the slope of all possible secant lines. So we're going to apply the difference quotient f of x plus h minus f of x all over h to our function f of x equals the square root of x plus 2. So first we step in, and everywhere we see an x in the function square root of x plus 2, we replace the x with x plus h. So step 1, set up this guy right here. So we get square root of x plus h plus 2 minus what? Minus the original function. So square root of x plus 2, square root of x plus 2, and this is all going to be over h. And then notice if we distribute the minus into the parentheses here, we get the square root of x plus h plus 2 minus the square root of x minus 2 all over h, and the 2's are going to give us a 0, so those go away, and we wind up with the square root of x plus h minus the square root of x all over h. And we could stop here and say this works and then move on to part B, but because it's going to be needed when we find slopes of tangent lines, I'm going to go ahead and use a technique we used in homework 3, and I'm going to rationalize the numerator. So I'm going to, as we did in homework 3, multiply the numerator by the conjugate, by its conjugate, by replacing the minus with the plus over here. So I'm going to go square root of x plus h, and instead of minus, I'm going to put plus the square root of x. And this is for practice. It's good to do this. And I can't just arbitrarily multiply by the conjugate of the numerator, so I have to do the conjugate over the conjugate so that this is a 1. So I'm multiplying by a funky form of 1. So I wind up with an equivalent statement. And when we multiply this out, when we do products of conjugates, we just get the a term squared minus the b term squared. So I get square root of x plus h times square root of x plus h is just x plus h minus square root of x times square root of x is x. I don't need to worry about the middle terms because with conjugates, the two middle terms cancel each other. And here in the denominator, I get h times the square root of x plus h plus the square root of x. And what I want to notice is that the square roots of, the x's in the numerator, give me a 0. I get x minus x is 0, which leaves me with just an h in the numerator. So I wind up with h over h times the square root of x plus h plus the square root of x. And h divided by h equals 1 as long as h isn't equal to 0. So if I step over here, I wind up with a final equation for the slopes of the secant lines as m secant equals 1 over the square root of x plus h plus the square root of x. So that finishes part A. Part B says find the slope of the secant line that contains the points 0, f of 0 and 4, f of 4. And so what we want to remember is that when we're working with the difference quotient, we're working over the interval x, comma, x plus h. So in this case, if we have x and x plus h, the x is the first x coordinate, which is 0. So we're working over the interval from 0 to 4, the closed interval from 0 to 4. So this tells us that x is equal to 0. X plus h is equal to 4. And h is, as it has been in all the other videos, is just the distance between these two x values. So it's just 4 minus 0 equals 4. And then those numbers can be plugged into the result that we got from part A. So the slope of the secant line through these 2 points is just going to be 1 over the square root of x plus h, but x plus h is just the second number 4, plus the square root of x right here, but x is just the first number 0 coming from here. So we wind up getting 1 over the square root of 4 is 2, plus the square root of 0 is 0, is just equal to 1/2. So the slope of the secant line through these 2 points is up 1 over 2, or 1/2.